Okay. So this is actually 58. It says state the value of the discriminant for each equation. Okay. Anybody remember what the discriminant is? I think I mentioned it to you a few days ago, but we talked about a lot of things since then, so maybe you forgot. Anybody remember discriminant, what that word means? The discriminant is b squared minus 4ac. And of course, when we're talking about a quadratic equation, a is the coefficient on x squared. So for this problem, a is 1, b is 4, and c is 3 for this particular problem. So we're just going to figure out what b squared minus 4ac is. So that would be b squared would be 16 minus 4 times 1 times 3. What did we come up with there? 16 minus 12, 4. So the value of the discriminant is 4. When that number is a perfect square, it means your problem factors. So just in case you were wondering, since 4 is a perfect square, I could factor that problem. What does it tell me about the number of real solutions? The number of real solutions will be 2 if the discriminant is positive. It will be 1 if the discriminant is 0. And it will be none if the discriminant is negative. So those are the rules. Well, we got a discriminant of 4, which is a positive number, which means we have 2 real solutions. The directions said, find the discriminant, and then determine the number of real solutions. So we found our discriminant, it was 4. That's a positive number, so there are 2 real solutions. All right, let's look at 17. So first of all, let's find the discriminant. All right, Hannah, what's our discriminant going to be? Set it up for me. Remember, this is it right here, b squared minus 4ac. So what's b squared? Minus 4 times 1 times 10. Good. So I'll figure that out. That's 16 minus 40, which is, I think, negative 24 if I did my arithmetic right. Yep, that's right. No real solutions. That's exactly right. Because your discriminant turned out to be a negative number. Let's try one more. How about 21? All right, James, let's figure out the discriminant. So what do we got?
25 minus 64.
Well, yeah, it's minus 4 times 2 times negative 8, which is actually, yeah, going to be plus 64 because you got the double negative there. So what is that, 89?
89.
So what does that tell you about your number of real solutions?
There are 2 real solutions.
There are 2 real solutions. And also, FYI, this problem doesn't factor, because the only time they factor is if you get a perfect square. 89 is not a perfect square. So if it cared, you could say it doesn't factor. Alright, are you okay with that? Alright, make sure you know the rules. You have two real roots if the discriminant's positive, one if it's 0, and none if it's negative. Alright, make sure you know those rules. Now, the next block of problems, 59, says now we're actually going to solve the equations. We're not just going to talk about what kind of answers they have, you know, like no reals or two reals or whatever. We're going to actually find them. So let's just look at number 2. Number 1's kind of tricky, but let's look at number 2. We could factor this, we could complete the square on this, but these directions say use the quadratic formula. Anybody remember the quadratic formula? DeAndre, do you happen to remember it? X equals
Negative b plus or minus the square root of b squared minus 4ac all over 2.
Out of what?
beautiful. There's your quadratic formula. If you don't already have that guy memorized, you need to get it memorized. Notice that that discriminant thing is right there, right? Right under that radical. All right, so here we go. Hannah, in our problem, what's A?
1.
B.
-1.
Good. And C?
-3.
Perfect. So if you know your formula, it's easy. You just put them in and see what happens. So here we go. X equals negative B. That means the opposite of B. Plus or minus the square root of B squared minus 4AC all over 2A. Now just be careful with your arithmetic. Look under this radical sign. Do you see this double negative thing going on? That's going to be a plus then. So we're going to have 1 plus so we have 81, the square root of, oh wait a minute, the square root of 81 is 9. Now did I skip too many steps there? Underneath here, I got 1 plus 80, which is 81, and the square root of 81 is 9. So 1 plus 9 is 10 over 2, which is 5. And 1 minus 9 is negative 8 over 2, which is negative 4. So the answer to the problem is 5 and negative 4. Now, that's probably boring you out of your mind because you are you've done the quadratic formula forever. Take a look at number 5. You guys are going to come up and do some on the board now. What's going on with number 5? You got to get the 3 to the other side because when you do the quadratic formula, you need it set equal to 0 so that you can see what your A, B, and C are. Right? Okay. So, Hannah, you got 5. DeAndre, you got 6. James, you got 7. All right?
I'm aboard.
Yeah. And I can only get 2 of you here, but would 2 of you do it here so it'll be on video? And then the other one can be on the other board up there. So we got 5, 6, and 7 going. Using the quadratic formula. And do not fear if you end up with radicals. You very well could end up with radicals. it's not, what's the worst that can happen?
Fix it.
That's right, we can just fix it. Uh-oh, help her out, DeAndre, she's stuck.
What happened?
What do you do?
Is it simplified to the fullest? Is 37 simplified now? If it doesn't, then you're done.
Is that good?
That looks like fine. It's all over two. Did you just put the 37 over two, or is it all over two?
Just doing the previous one.
No, it's just that
It's
small.
all over two.
I'll leave it in radical form. All right, let's take a look at them and see how we did. -2 plus or minus 2, 3. Okay, 6 is right. 5 is right. Now, James, let's look at this one for a second. You are right. Wait. Yeah, you are right, except for, what about Route 40? If we're gonna leave things as a
Oh,
radical,
yeah, that's what you're saying.
40 will actually break down, into 4 times 10. So that would be 2 root 10.
Yep.
So you have -2
Simplify.
plus or minus 2 root 10 over 6.
Simplify.
And now you see a 2, a 2, and a 6. Remember, all things outside the radical. So -1 plus or minus root 10 over 3. There would be your answer. So you were absolutely right on target, you just weren't quite done.
Yeah.
How are we with the quadratic formula? Are we okay with that?
Good.
Okay, what's our rules for the discriminant again? If the discriminant is positive, we have 2 reals. If it's 0, we have 1. And if it's negative, we have none. They're imaginary. We have no real roots. Okay, all right, so now we're moving on, marching ahead. Part 60 says, simplify each expression and state the excluded values of the variables. Now, the simplify part is probably pretty easy for you. Look at number 60, or part 60, number 1. We have 12ab over a squared b squared. Now, when I say simplify, what do you think we're talking about doing here? Just canceling, right? Yeah, just canceling. So I got the 12, nothing to do with that. What's going to happen here with the a's? Well, there's 1 on the top and there's 2 on the bottom. So 1's going to be on the bottom. Think about canceling them out. Don't you have an extra 1 on the bottom? What about the b's? Same thing. So part 1 says simplify. All right? Now part 2 says state the excluded values of the variables. What that means is, look at your original problem. A cannot be 0 and B cannot be 0. Those are the excluded values. Because what would happen right here if A were 0? It'd be 0. And what do we know about 0 in the bottom of a fraction? Not allowed. It's not okay. Same thing with B. So these are called the excluded values. A and B cannot be 0. If we had something in our denominator that was like this, then we would say A cannot be 4. You just don't want your denominator to be 0. Okay, let's try the next one. Number 2. All right, let's simplify. So we have 7n cubed over 21n to the 8th. So we're going to simplify. Now this time, you got a 7 over 21. What's going to happen there?
It's gonna simplify to 1/3.
It's going to simplify to 1/3. Now you got 3 n's on the top and 8 n's on the bottom. Don't make this complicated.
And to the fifth
What
power.
what happens?
They just subtract it out.
Yeah. You think about canceling. You got 3 m on top and 8 m on the bottom. Where are the leftovers going to be? Bottom. How many are there going to be? 5. 5. Not 3. 5. So your answer is 1 over 3n to the 5th. Go back to the original problem. Is there anything that n is your only variable, is there anything n can't be? Yeah, n can't be 0. That's your excluded value. Let's look at number 4. What do you think you're going to have to do first with number 4? It's a little bit more complicated.
Factor.
Yeah, you're going to have to factor it. Oh, yay, Hannah, we're going to get to factor some more. Now, this is not a bad factoring problem, though. This one's not bad. What do we have up on top?
Difference of squares.
Difference of squares. So that will be,
M plus 2, minus 2.
all right, Hannah, this is good review. M plus 2, M minus 2. What about the bottom?
M plus 2, M plus 4. Cancel the M plus 2.
No canceling until we factor. As soon as you get it factored, then you're allowed to cancel. In other words, groupies, nobody's canceling these m squareds here. You cannot just start canceling. You have to factor first. So we've got factored, those go away. We're left with n minus 2 over n plus 4. So that's the simplified answer. To find the excluded values, you gotta go back to the problem before you cancel. So we're going back to the original. What are the excluded values? M can't be what?
So minus 2.
Negative 4.
-2 or -4. Can't be either one. The excluded values come from the original problem, not the canceled out problem, the original problem. Hannah, is that making sense to you? All right, let's get 5, 6, and 7 put up on the board then. Make sure you put the simplified answer and your excluded values
There's some.
for 5, 6, and 7.
And you tell me that first.
Which one are you guys doing?
And then 7.
What do we do? 5.
You guys are so polite. it exactly. So there's your simplified answer. That's correct. You're done. You don't even really need those parentheses for this time. It doesn't matter. They're fine. Go back to this now. What can X not be? One and negative one. Because you don't want this to be zero. So what would make X zero? Negative one? Yep, can't be. And then X can't be one. Yep, that's exactly right. Yes, the denominator is the only part you look at. When you want excluded values, good point. When you want excluded values, they come from the denominator, period. Okay, so this one, that looks good, very good for that one. And number, what is this, 7? Very good. Now, James only had one excluded value. The rest of you guys had 2. James only had 1 because his denominator factors were the same. So X couldn't be negative 2, period. Any issues with that? Excluded values come from the denominator. What makes the denominator 0? All right, the next part, which I can't read, I think, is that 61? 61 is almost the same thing, except you're going to multiply a couple of these together. So, for example, in number 1, this is 61, 1. You have this guy, and then times another guy. What do you think you're going to do with this? Just take a wild guess. What if you found this in the hallway? What would you do with it?
What would I do first?
Yeah.
First, I would simplify by cross simplify.
Okay, when in a multiplication problem, you are allowed to just like connect that. So anything on the top cancels with anything on the bottom. Okay? So if you want to cancel out this a squared and this a squared, you are perfectly able to do that. This b might cancel with one of those b's. So I have 6a over b cubed. Multiplication problems are the best because you can mix and match canceling, and in the end you just put everything together that you still have. There's no common denominators, there's no worrying about anything. They are so good. Multiplications are so good. Let's look at the next one. MP squared over 3 times 4 over MP. Okay, now be careful, that's a p squared.
Yeah, so the m's are going to be completely gone.
M's are going to be completely gone. Good.
The p is going to be gone out the denominator. You'll have 1p on top. It'll be 4p over 3.
Done. He did that very fast. Did the rest of you keep up? Now 3 is a little bit bigger, but the principle is the same. In a multiply problem, everything goes. So you see these x minus 4s? Gone. You are only allowed to do that in a multiply problem, you guys, so keep track of that. Multiply is easy. We love multiply. But what we do in multiply can only be done in multiply. So our answer, x plus 2 over x minus 1. Let's try a harder one. Look at number 6. Hannah, what do you think we're going to do with number 6? Look at this. It's huge. What do you think we might do with that? Huh? We what'd you do down there? Yeah, you're gonna factor everything. Everything that factors, you're gonna factor. So how does this factor, this numerator right here? What do you think? Yep. Beautiful. X plus 8, x minus 8. Beautiful. Now how about the denominator? Can I do anything with that? Pull out a 2. And I'll be left with x plus 8. And this stuff over here. Nothing to do with x plus 8. You can't factor that, so it just stays. What about this? This factors. How would that factor? Walk your way through it. So we got an x and an x. Okay, now you want to, what times what gives you 64? So x plus 8, x plus 8. Would that outside and inside give me a 16? Yeah. Okay, factored. Start canceling. All right, so this will cancel with this. This will cancel with this. So on top, all we have left is x minus 8. And on the bottom, we have a 2 and an x plus 8. And we're saying, you can, you do not have to. Doesn't matter one way or the other. You certainly can, but you don't have to. All right, now we're ready for the other side. We're each going to practice one of these. So 7, 8, and 9. Let's get them on the board. 7, 8, and 9. I try to write big enough that it can be picked up on the video if you're over here on this side.
I'm doing 7.
You're doing 8, I think. Because you're doing 7, right, Deandra?
Yeah.
And James, you're doing 8? I mean 9.
9,
You're
yeah.
doing 9. So Hannah, you have 8. Tell me if you're stuck, Hannah. No, you don't. You can if you want, but you do not have to. James, you got a little bit tricky with that. You can do it. I am confident. Hannah, can we meet for a couple hours on Thursday? Why not? Honey, I know you're not busy at 8 in the morning. But what time's brunch? Okay, you need to do that, okay? Because we're trying hard to get this done. full day off, I just don't think we'll get it done. Without, I mean, needing for some hours on Saturday and Sunday, as it is, we're probably gonna have to meet one day or the other. So if we could get a couple hours in on Thursday, that would be very helpful.
You're gonna have to meet on Saturday or Sunday.
So.
I can't meet on Sunday.
Saturday.
And I have no problem, I mean, if we need to meet at 6 a.m. on Thursday, I can do that, so we're done by 8, so you can do brunch at 9. I mean, I can do that. I'm not sure how
I
popular.
don't know if I can do that. I can't get up there.
Alright, so let's see what we got here. Let me check, number 7. Good, that is correct, so look that over if you have a question. What'd you end up with here, James? Is this the final answer?
Yep.
You are absolutely correct. He had a little bit harder factoring in his problem, and Hannah's is also correct. Now, Hannah's question is, you guys were left with just, one parentheses on the top and one on the bottom. She had 2 parentheses left on the top, and she said, should I FOIL those? And the answer is if you want to. Doesn't make any difference, it's fine. That section's easy, so we're ready for the next one. Now, the good news is section 62 is exactly the same, except, anybody remember how we divide when we have fractional expressions? Like we have 12AB,
We flip it.
yeah. So we're gonna do this exactly the same as a multiplication, except we have to flip this one over. So 12AB over A squared B squared times A over B. When you divide by a fraction, you multiply by its reciprocal.
Which one is this?
This is 62, number 1. 62, number 1. Alright, so we got this, and we're going to turn it over and multiply by A over B. Alright, so then we go just like we have been. So I notice on the top I have an A and an A that'll cancel with that. I have a B that'll cancel. I got 12 over B squared. What about you guys? So number 2, it's a division problem, so we copy the first one and flip the second one. And everything cancel anywhere we want, so we just get P over 4. Alright, I'm going to skip down to number 6. Hannah, are you seeing how these are really the same as the ones we just did? They just have that first step that's a little bit different. So I have to flip that second one. Turn it into a times, flip it over. And then what do I need to do?
One side is all differences squares.
I gotta factor.
Undo those.
Yep. Remember, you can't cancel until you factor, right? So we're gonna factor y minus 6, y plus 6. Y minus 7, y plus 7. And then so we end up with y minus 6 over y minus 7. Boy, those are fun. Those are fun. We know what's going to happen now, right? So 7, 8, and 9, if you would mind getting those on the board for us. 7, 8, and 9.
I'll do now.
Alright, so 789, here we go. You guys are fast. Well, the two on the bottom can be multiplied together, because that's all a multiplication problem. And then you have an 8 over an 18, so that's just like reducing in a regular fraction. What was an 8 and 8? 2? Yeah. 2 days and 8, 4, 2 days and 18. Don't just guess, use your calculator if you need to. Good job on that. The rest of all the letters are right. Good work. Anybody have an issue? Everybody looks good, everything's right? Alright, then let's look at the next section. It is another quotient section. The only difference is these are written sideways instead of up and down. So number 1 is x cubed plus 2x squared minus x divided by x. That's easy. Take an x out of everything, right? So you can think of that like each of these over x, just canceling out an x. So we have x squared plus 2x minus 1. So nothing different here, except they're written sideways with the division symbol. So number 2, you have each of these things, you have all these things divided by 2x. Everything is divided by 2x. So what are we gonna have here in the beginning? X squared.
Plus 6x.
Anna, you paying attention?
Yeah.
Okay. Wanna look at number 10? This is full of letters, kinda like Hannah's was a minute ago. I wanna show you something. Oh shoot, I'm out of room over here. So all of those are over 2a squared b squared. So, one term at a time. There are 4 things on top. Each one of them is over 2a squared b squared. What happens, do it a term at a time, what happens there in that first term? What are we left with when we start canceling? An a and a b, that's it. Now move on to the next term. What are we left with here when we start canceling? Just a 4. Nothing's left but a 4. Would you agree? Alright, how about this guy? It's gonna be a minus. 5 on top, and an A and a B on the bottom. James?
Another question, like, would it be, like, acceptable to put, like, maybe, like, 5/8 in the negative first and B in the negative first?
Actually, it's the equivalent thing, but there's kind of a rule. You know how we have a rule that says no radicals in the bottom?
Mm-hmm.
We have a rule that says no negative exponents. So it would be, that's the same as 5/8 in the negative first, b in the negative first, but this is considered good form.
Okay.
And then finally, what's the last one?
6 over a squared b squared.
6 over a squared b squared. If you only have one term in the bottom divided by, you're only dividing by one term, this is the best strategy. Do each term individually in the numerator. When you have one like number 11, then you've got to go back and do what we were doing before, which is what? What are you going to do with that? FOIL. You're going to factor it. Yeah, you're going to factor it. When your bottom is not a single term, when your bottom is something like this, you need to factor so that you can cancel it. That's the only way you can cancel it. So that answer would be b minus 3. Wow, I got a ton of problems here. So, why don't we try, all right, everybody's going to do 2 problems, okay? So I want, Hannah, I want you to do 13. And DeAndre, I want you to do 17. And James, I want you to do 18. And then I want everybody to do 19.
On the board.
On the board, yep. On the board. Did you go through this already down here?
Oh yeah, I didn't put 9 up there, or 19.
Yeah, we'll put 19 up there. I want to see if everybody gets the same answer. everybody should have gotten the same answer from 19. We did. We're awesome. James, good. DeAndre, good. We okay? All right. We're time for another quiz before we start the add subtract. So I'm going to give you your practice quiz. When you are done with the practice quiz, you can take a little break